Okay, algebra folks, this is Unit 9, Notes 4. Good news is you're in the home stretch. After this you take a quiz and then 5, 6, and 7, and that is the end of algebra. But for right now, what we're talking about is multiplying rational expressions. So a rational expression is basically pretty straightforward. You multiply the numerators, you multiply the denominators, simplify what is left, and don't forget to tell me what can or cannot happen with the denominator. So if you take a look at something like number 1, there's a lot going on here. So what I would look to do is this. What can I start simplifying right away? So what I'm looking at is, you know what? 5 over 15 can be simplified to 1 over 3. 16 over 8 can be simplified to 2 over 1. So now that takes care of the numbers. So now I've got to start looking at the variables. So I've got a to the first over a squared. So I've got a right here over an a squared over here. So that's going to cancel out, and this 2 is just going to become a 1. So then I've got b to the third and b over here. So that is like 3 minus 1. So this is going to become b squared, and this b is going to go away. Then last, I've got c cubed and c squared. So this is going to cancel out. So 3 minus 2 is going to be 1. So I'm going to have c to the first. So I'm going to have 2b squared on the top and c. Then on the bottom, I'm going to have 3a. So once I simplify everything, that's what I've got. And then all I have to do is after that is say, you know what, a cannot equal 0. Because if a equals 0, then that whole thing is 0, being divided by 0, and I can't do that. Similar idea here for number 2. This one's a little bit more straightforward. 16 over 8 is 2 over 1. Now, 3 over 32 doesn't do me any good. 32 can't be divided by 3, but 2 over 32 can. So I can take 2 over 32 and change that to 1 over 16. So right now in the numerator, I've got a 3, and in the denominator, I've got 16. So now I can do a couple different things here. One, I've got g here, and g here. So if I just look at the g's, I've got g squared and g squared, so that becomes g to the fourth, over just a g in the denominator. So that's like g to the first. So 4 minus 3, so 4 minus 1 gives me 3, and it's positive, so that puts it in the numerator. So I'm going to have 3g to the third in the numerator. And that gets rid of all the g's. Now if I look at h's, I've got h to the third and h, and over h squared. So if I look at just h's, that's h to the third times h over h squared. Well, h to the third times h is going to be h to the fourth. And when I subtract those two, I'm going to have h squared in the numerator. So that gets rid of all the h's. Oh, sorry, I forgot an h. I forgot this h right here. So, let's erase this. I remember this h squared, but I forgot this h. So this is actually h to the third. So this cancels out. So I don't have h squared in the top. I've got h just alone in the top. Then all I got left is just this j squared over here. It's in the denominator. There's no j's in the numerator. So I just put j squared in the denominator because it doesn't really go with anything else. And then I just say, you know what, j can't equal 0. Because if j equals 0, then I'm dividing by 0. And there's my answer right there. So if I multiply something with a polynomial, multiplying with a polynomial gets a little bit tough. Okay, the previous slide, the previous notes, that was all one monomial, and that's what you're dealing with. Now I'm dealing with things like this. Okay, so if I look at one like number 3, take a look at what I'm dealing with here. So what I want to do first is factor anything that can be factored. Okay, this one's good, this one's good, this one's good. Here, you know, if you want to draw your x, draw your x. I happen to know that it's x minus 5 and x plus 3. So now I want to simplify it. Well, this is an x minus 5, this is an x minus 5. Those two are going to cancel each other out. So then you have x squared over x. Well, x squared over x just becomes x in the top, nothing more in the bottom. So on the top, all I've got is left is x. On the bottom, all I've got left is x plus 3. So this is my simplified answer, but I'm not done yet. I've also got to say, you know what? X plus 3 cannot equal 0. So x cannot equal negative 3. Because if x equals negative 3, that means that denominator, this bottom part, is going to equal 0. That means I'm dividing by 0, and I can't do that. So number 4, same kind of idea. You know, this one right here is about the only one I can factor. So if you want to draw your x, draw your x. You know, you should end up with x plus 4, x plus 3. This is why I emphasize to you guys, be good at factoring, because it's going to come back. So if you look, I've got x plus 3 on the top, x plus 3 on the bottom, so that cancels out. And nothing else really goes. So I've got 5 on the top, x, and x plus 4 on the bottom. Now if you look, I've got two things here, x and x plus 4. So I got to say both of those things cannot equal 0. So x cannot equal 0, and x plus 4 cannot equal 0. So x cannot equal negative 4. So this is my solution, and these are my limitations down here. X cannot equal 0, x cannot equal negative 4. So now we're starting to get a little more complicated. So if I look at number 5, this kind of gets to be a little bit messy. So let's start factoring things. So if I factor this top part here, that becomes y minus 4, y plus 1 over y plus 5 times y plus 5. Then if I factor this one, it becomes y minus 4. Now, don't start thinking you can just start canceling out just the y's and leave everything else. You cannot do that. Okay, so let me rewrite this. So this is going to be y plus 1. You cannot do that. You can only take these things as binomials, okay, or trinomials. But you can only take either one thing at a time or binomials. So y plus 5 over y plus 5 cancels out. Y minus 4 over y minus 4 cancels out. What I'm left with is y plus 1 over y. So don't think that you can cancel these out and tell me that my answer is 1. No, you are going to be wrong. Don't do that. This is a big fat no, it's not that. Your answer is going to be y plus 1 over y, because you got to combine these two things first. So, but what you also have to tell me is y cannot equal 0. So for the bottom part, same idea. You have b plus 3. On the bottom, if I factor out 4, I have b minus 3. Those two can't do anything. Up top here, looking at this one, that's going to be b minus 3 and b minus 1. And on the bottom here, that's going to be b, I think it's going to be minus 10 and b plus 3, factored. Okay, again, I told you before and tell you it again. Really pays off to be able to factor and do it well. So now we start playing canceling games. B plus 3 cancels out. You can only cancel off one on top, one on bottom. So b minus 3 over b minus 3. So what am I left with? Well, on top I'm left with b minus 1. On the top I'm left with 4, b minus 10. So b minus 10 cannot equal 0. So b cannot equal 10. There's my limitation. There's my answer. Thank you for playing. So now, 25 lights around a patio. Each light is 40 cents. Each light is 40 watts, and the cost of electricity is 15 cents per kilowatt hour. Write an expression to calculate the cost of using the light for 3 hours. So, each light is 40 watts. There's 25 lights. So 40 times 25. So 40 times 25 is 1,000. So 1,000 watts total is what it takes to run this thing. Well, 1,000 watts is also 1 kilowatt. Okay? So if it's 15 cents per kilowatt hour, write an expression to calculate the cost of using the light for 3 hours. Well, all you're going to do is take basically 1 kilowatt times 0.15 times 3. Okay? So this is how much, this is your wattage, this is your cost, and this is your time. So depending on what the variable is, so it's going to be 0.15 times 3. So this whole thing takes 45 cents to run for 3 hours. Okay, so 25 times 40 is where I got the 1,000. All right, in the 2004 Summer Olympic Games in Athens, Greece, Justin Gatlin won the gold medal for a 100-meter sprint. His time was 9.85 seconds. What is his speed in kilometers per hour? Okay, this takes a little bit of time, and your science teachers will thank you for doing this correctly. Okay, so he ran 100 meters in 9.85 seconds. You want to convert that to kilometers per hour. Okay, so what you have to do is this. So you need to convert this top one to kilometers. Well, there's 1,000 meters in 1 kilometer. Okay, so there we go. Now we're in kilometers. So meters and meters cancels out. So now I've got to go from seconds to hours. So there are 60 seconds in 1 minute and 60 minutes in 1 hour. Okay, so the seconds cancel out, minutes cancel out. You're left with kilometers and hours, and that's kind of what you want. So basically, I multiply top, 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 and divide it by bottom, bottom, bottom. So I'm going to take 100 times 60 times 60. And I'm going to get 360,000. And I'm going to divide that by 9.85 times 1,000. So I end up with 36.5482 kilometers per hour. So that's how fast he's running when he ran his 100-meter dash. So the velocity that the spacecraft must have in order to escape Earth's gravitational pull is called the escape velocity. It is 40,320 kilometers per hour. What is that speed in meters per second? Okay, so again, same kind of setup. You're going to take 40,320, and that's going to be kilometers per hour in 1 hour. So now you're going to kind of go backwards, and you're going to kind of break this apart. So realize that 1 kilometer, and you're trying to get to meters, is 1,000 meters. Okay, then you're trying to go from hour to second. So now you're going to go 1 hour is 60 minutes. And you got to go one step further. You got to say, you know what? 1 minute is 60 seconds. So that's a C. So now you're left with multiplying the top together and dividing by the bottom. So you're going to take 40,320 times 1,000. So you get a really big number, 40,320, and then followed by 3 more zeros. So you get 40,320,000, and you're going to divide that time by 60 times 60. So you're going to take 40, and so it's going to average about 11,200 meters per second. So that's really moving.